In 1877, the monsoon vanished across the globe. Within months, an estimated 5 to 10 million people died of starvation in British India. Northern China lost 20 million people. Brazil lost 2 million more. No world war, asteroid, or deadly plague caused this planetary collapse. The root cause was born thousands of miles away. A patch of water off the coast of Peru warmed up, triggering a massive natural cycle known as a Super El Niño. That 1877 tragedy serves as our historical baseline. It proves that a single oceanic temperature cycle possesses the raw thermal energy to vaporize rainfall across multiple continents and shatter agricultural economies. When human civilization ignores oceanic temperature anomalies, millions die. Recognizing the patterns early is our only method of survival. Right now, the world's premier weather forecasting agencies are tracking a massive, deep oceanic heat reservoir surging toward the surface of the Pacific. This data suggests a sea surface temperature surge that could reach 3 degrees Celsius above normal. If those projections hold, 2026 will surpass every documented record in human history. The scientific community is deeply terrified because this upcoming weather event is not hitting the pristine, stable climate of 1877. This climate beast is returning to a planet already choked by global warming. Stacking these two massive heating forces sets us up for a collision the human race has never experienced. To understand how a patch of water can destroy an economy, we have to look at planetary mechanics. Atmospheric physics dictates one strict rule: wind always flows from high pressure to low pressure. In this diagram of the Pacific Ocean under normal conditions, steady trade winds push a colossal pool of warm surface water westward toward Asia and Australia. This warm water evaporates rapidly, fueling their torrential monsoon rains. As that warm surface water is dragged away, freezing, nutrient-rich deep water rushes up to replace it along the coast of South America. This upwelling keeps the eastern Pacific cool and dry. An El Niño is a mechanical failure of this exact system. The trade winds stall. Without that pressure, the colossal warm pool slides backward to the east. The rain clouds follow the heat, throwing the entire global weather engine into reverse. When ocean temperatures cross a 2-degree threshold over thousands of kilometers, it triggers a planetary mechanical failure that throws the entire world's weather patterns into chaos. This reversed atmospheric engine poses a catastrophic threat to the Indian subcontinent, where the food supply for over 1 billion people is built on the predictable arrival of natural rainfall. Roughly half of India's farmlands have zero access to artificial canals or tube wells. Millions of farmers rely entirely on the heavy monsoon to flood their fields and sustain the national food supply. El Niño attacks this vulnerability. The warming Indian Ocean shrinks the critical pressure gap needed to pull moisture-laden winds inland, causing the monsoon to fail. During the exact months when critical crops require water the most, the rains arrive late and dangerously weak. The soil cracks dry, and agricultural yields collapse. El Niño specifically targets a nation's structural reliance on rain, transforming an atmospheric anomaly into a direct economic drought. But there is a secondary variable that makes 2026 uniquely dangerous, a threat most media networks ignore: the baseline trap. This graphic shows the core mathematical threat. In 1877, the background temperature was stable. Today, human-driven climate change has already inflated our global baseline by 1.4 degrees Celsius. A Super El Niño stacks its own massive heat spike directly on top of our artificial warming. In our rapidly expanding cities, the earthing heat island effect acts as a localized multiplier. Concrete jungles absorb this compounded heat during the day and radiate it out at night, eliminating the human body's ability to cool down and recover. This trapped thermal energy physically batters vulnerable populations trying to navigate extreme daytime temperatures, multiplying the risk of heat strokes and organ failure. When nighttime temperatures spike, the body loses its only window for physical recovery. Unless we intervene, this compounded heat transforms a seasonal weather event into a lethal crisis. While an oceanic cycle is an unstoppable force of nature, our vulnerability to it is entirely a choice. Governments must rapidly deploy structural retrofits, starting with a massive disruption of agriculture's deadly dependency on the unpredictable monsoon. This field layout shows exactly how we adapt. Governments must subsidize and mandate high-efficiency technologies like precision drip irrigation, delivering water directly to the roots to maintain crop yields during severe droughts. We must also upgrade our strategic food stockpiles. Holding robust reserves inside massive storage facilities creates an economic shield against crop failures and food inflation. Looking at this expansive flat rooftop, we see the immediate solution to the urban heat trap. Mandating cool, reflective roofs on warehouses and public buildings bounces sunlight back into space, lowering indoor temperatures without stressing the electrical grid. These systemic infrastructure upgrades are not optional luxuries. They are mandatory defensive shields required to prevent economic collapse. Government policy is essential, but collective individual action is just as critical for surviving the summer of 2026. You can break your dependency on the fragile, coal-burning grid. Installing localized solar panels on a private roof or balcony gives you immediate control of your energy, keeping fans running when extreme heat causes blackouts. We must also extend active community care to informal and outdoor workers. Delivery drivers and laborers bear the physical weight of this heat. Make it a rule to provide cold water, electrolyte drinks, and a shaded resting space to anyone working outside your home. Become a guerrilla environmentalist. Protect mature, old-growth urban trees from being cut down for commercial paving. They act as vital local air conditioners. We possess advanced satellite tracking, micro-irrigation technology, and the systemic capability to outsmart this natural cycle. Demand structural infrastructure from your policymakers. Take these local steps in your own neighborhood, and subscribe to the channel to help spread these tactics for a warming world.